Hello students, welcome back to my 8th lecture on basic maths. So in our previous lecture, that is lecture number 7, we dealt with the second chapter, that is sets, relations and functions. Today we shall start with the operations on sets. So let's get started. In operation on sets, we will see some different types of sets. So in that, the first type is union of sets. So here, let A and B be any two sets. Then the union of A and B is denoted by A union B is defined to be the set of all those elements which are in both A and B. I repeat, the set of all those elements which are both in A and B, we will combine together to form the union of sets. For example, let A is equals to the elements A, B, C and set B have the elements C, D, E and F. So, set of all those elements which are in both A and B is written in the form A union B, which is equals to A, B, C. Here students, you observe C is in both A and in set B. So you write once only. That is C, D, E, F. Second example, A is equals to 1, 2, 3, 4, 5 as elements and set B contains the elements from 1 to 9. Now, A union B is written as set of all those elements which are both in A and B will be equal to 1, 2, 3, so on till 9. We will write all those elements which are both in A and B. So, second type, that is intersection of sets. Let A and B be any two sets, then the intersection of A and B denoted by A intersection B is defined to be the set of all common elements between A and B. I repeat, the set of all common elements which are both in A and in B. For example, let A is equals to A, B, C, D are elements. B set contains the elements C, D, E, F, G, H. Now find the common elements in set A and B. Here, after observing, we get two elements which are common in both A and B. So we will write it as A intersection B is equals to C, D. Similarly, one more example. Let A is equals to 1, 2, 3, 4, 5 and say set B contains the elements 1 to 9. Now, the common elements between A and B are 1, 2, 3, 4, 5. That is nothing but the set A itself. Next one, difference between any two sets. Let A and B be any two sets. The difference between A minus B is defined to be the set of all those elements of A which are not in B. It is also called the complement of B with respect to A. Similarly, B minus A is defined to be the set of all those elements of B which are not in A. It is also called the complement of A with respect to B. For example, set A contains the elements A, B, C, D and set B contains the elements D, E, F, G, H, I. Now, A minus B is defined as the set of all those elements of A which are not in B. Now find the difference between A minus B. That will be equals to, now when you subtract these two elements, D and D only will get cancelled. So which all elements will remain in set A, that have to be written in the set form. That will be A minus B is equals to A, B, C with respect to A. Similarly, B minus A is written as, it is defined to be the set of all those elements of B which are not in A. So in such cases, only D will get cancelled and remaining elements which are in B have to be written in the set form. E, F, G, H and I are the elements. Difference between B minus A set is written like this. Next type, that is symmetric difference. Let A and B be any two sets. Then the symmetric difference between A and B is defined to be A minus B union B minus A and is denoted by A delta B. For example, A is equals to A, B, C, D elements and set B contains the elements D, E, F, G, H, I. Now find the difference between A minus B. That will be, here again D and D are common, they will get cancelled. With respect to A, which all elements are there in set A, that you have to consider as A minus B. Similarly, for B minus A, find the difference between B and A. You get the elements E, F, G, H, I. As D and D are common, they will get cancelled. So we have to write the elements which remain in the set B. Now symmetric difference will be A delta B is equals to A minus B union B minus A. That will be equals to, write down A minus B elements as a sets and also B minus A elements together. Union of A minus B and B minus A is nothing but A delta B. You will get A, B, C, E, F, G, H, I. Next one, complement of a set with respect to universal set. Let A be any set, then the complement of A with respect to U is the set of all those elements of U which are not in A and is denoted by U minus A or A dash or A raised to C also we can write. Algebra of sets we will see now. In that we see some laws. They are commutative law, associative law, distributive law. So first form is associative law. If A and B are any two sets, then these two properties holds good for both union as well as intersection. They are A union B is equals to B union A, and second one, A intersection B will be equals to B intersection A. So let's consider with the one example. Let A is equals to 1, 2, 3, B is equals to 2, 3, 4 are the elements respectively. Now find A union B, that will be equals to all the elements together we will write 1, 2, 3, 4. Similarly, for the set B union A, which have the elements 1, 2, 3, 4. So here in this case we can see both are equal to each other. A union B is equals to B union A. Similarly, for intersection, A intersection B will be equals to find the common elements from set A and set B. You will get 2 and 3. Similarly, for B intersection A, you get the same elements 2, 3. Hence, we can say that A intersection B will be equals to B intersection A. Now, second law, that is associative laws. If A, B, C are 3 sets, then these two properties holds good for associative law. They are A union B union C will be equals to A union B union C. Also, A intersection B intersection C will be equals to A intersection B intersection C. Students, I will leave this for you. So, you take the same example as set A and set B from the commutative law and perform this. You have to get both set equals to each other. You consider one more set C here. Take the values 4, 5, 6. Now, then perform the law. Next one, distributive laws. If A, B, C are any 3 sets, then A union B intersection C will be equals to A union B intersection A union C. And second one, A intersection B union C will be equals to A intersection B union A intersection C. Now here see students, the first part in the first question property will be A union B intersection C will be expanded as, here in the bracket we have intersection that will come out and group A union B and again group A union C. So in this case we have to get both LHS and RHS answer equal to each other. We will do this by taking one example. So let us consider set A, B, C with the elements 1, 2, 3, 4. Set A have the elements. Set B contains the elements 3, 4, 5, 6. And set C contains the elements 4, 5, 6, 7, 8. Now, take LHS from the first main, that is B intersection C, bracket 1 you have to solve first. So, when you combined these elements B intersection C, we get 4, 5, 6 common elements. So, that you write one side. Then, A union B intersection C will be, A set you write down, that is 1, 2, 3, 4 union, next B intersection C elements you have to write 4, 5, 6. Now since there is a union, so here in the condition for union you have to write all the elements which are in A also and B also, that is equals to 1, 2, 3, 4, 5, 6. This is your LHS answer. Similarly, go for RHS. Take A union B, combine them, you get the elements 1, 2, 3, 4, 5, 6. And A union C is equals to 1, 2, 3, 4, 5, 6, 7, 8. Now, intersection from these two sets will be, that is A union B intersection A union C will be equals to, which are common among these two, you select and write it down as an answer. That is 1, 2, 3, 4, 5, 6. These elements are common among these two sets. So hence from 1 and 2 we can say that LHS and RHS are equal to each other. Similarly, go for second one. Same process you have to do. You will get the answer. I hope students you will do it by yourself. Next, one more important law, that is De Morgan's laws. If A and B are any two sets, then A union B, the whole complement will be is equals to A complement intersection B complement, and A intersection B, the whole complement will be equals to A complement union B complement. Now we will prove these properties by taking the example. So let us consider the union element, universal element, that is equals to 1, 2, 3, 4, 5, 6, 7, 6, 8, 9. From this there will be 7 also, students. You take 7 also. Now from this only we have taken subsets as A and B, that is 1 to 5 set A, and set B contains 3, 4, 5, 6, 7. Now first take LHS in that, solve for the bracket form, that is A union B is equals to 1, 2, 3, 4, 5, 6 and 7 are the elements. Together we are writing from the set A and B. Now complement will be written as A union B, the whole dash will be equals to U minus A. You just please note down, students. A union B, the whole dash will be equals to U minus A. When you subtract U and A union B, you get some elements will be cancelled. They are all 1 to 7 elements will cancelled from U. The two elements will remain. They are 8 and 9. You consider this as 1. Then go for A dash. A dash you will get when you subtract U and A. Subtract U and A, you get the elements 6, 7, 8 and 9. Similarly, B dash you will get by subtracting U and B. The elements will be 1, 2, 8, 9. Now, combine these two sets, that is the common elements A dash intersection B dash will be equals to 8, 9. Consider this as second equation. Now compare first equation with second equation. Since the elements are same only, hence we can say that from 1 and 2 we have A union B, the whole dash will be equals to A intersection A dash intersection B dash. Hope you are understanding this. So can you try for the second one? A intersection B, the whole dash will be equals to A dash union B dash. Now the next very important concept, that is Venn diagram. So diagrammatic representation of sets and their properties of sets is called Venn diagram, in the name of the famous mathematician Venn, who devised it. So the properties are: a set is represented by a circle or a closed figure. A set is always in Venn diagrams we represent a set by drawing a closed figure. It will be circle only. Either A, here see A is a circle and B is in the oval form. Second one, universal set is represented by drawing a rectangular diagram, and A union B is represented as within a square or rectangular set, universal set, we write both the set which are shaded. Here why we have to shade A union B means both we will write together in this. The elements which we will combine both A and B have to be shaded. Hence the shaded portion is A union B. Similarly, A intersection B in this set, we shade only the common part, as in the intersection the common elements which are both in A and set B will be written. Hence only this middle part will be shaded as the portion A intersection B. Now A in minus B, the elements which are in A but not in B, that's why we will shade only A part excluding B here. For difference between B and A, B minus A, we will shade only B part excluding A, which are not in A but in B, we will shade that portion, that is B minus A. Similarly, A delta B, symmetric difference between A and B, that is A minus B and B minus A, will be shaded like this. Draw two circles and the common part you leave it, remaining portion you have to shade. And eighth one is subset. A is a subset of B, will be shaded, will be represented like this. Set A, here A is a subset of B, so B is a bigger one, bigger circle is B. In that some elements have to be taken, will be represented by a small circle. Next, ninth one, A complement or U minus A. So by definition, here which are in U and A, the difference between U and A will be represented, the elements which are in U but not in A have to be shaded as A complement. The remaining elements you have to write. So here the shaded portion is U minus A or A dash in union universal set U. Last one, they are disjoint sets. If two sets are different, for example, A is having even numbers, set B contains odd numbers, then there will be no matching. A intersection B is not possible. So we will write A intersection B is equals to null set. So we will represent two circles within a universal set separately. We will not mix them together. Hence this is a disjoint set. With this I will conclude, students. You write down all the notes in your fair book and we will do the exercise related with Venn diagrams as well as De Morgan's law in our next class. Thank you.